All right, my athletes, here we are finding the general form of a line quickly. So remember, general form of the equation is ax plus by equals c. Our a is always associated with our x term, and our y is always associated with our b term. You identify general form when your x's and y's are on the same side. Okay, so what we can tell with our general form here is that you can find the equation or find the gradient of your general form being negative a over b. So if I have an equation like this, I identify my a being 2, my b being 3, and I make the opposite. So the gradient of this general form equation is negative 2/3. So let's see how we can apply that. So find the equation of a line with a gradient of 3 over 4, which passes through 5, negative 2. So I'm going to use this bit of information right here. So from that information, I can go ahead and say that 3x minus 4y is equal to c. Okay? I could also say, because I know it's just negative a over b, okay, I could also do it as negative 3x plus 4y is equal to c, and both those solutions will be correct at this point. The second piece I have to do is now utilize this information that it must satisfy the point 5, negative 2. Remember, 5 is our x value, negative 2 is our y value. So utilizing those points, we can solve for the last part of our equation c. So as we put these in here, I'm going to use this top equation. So I'm going to go 3, substitute in my x value of 5, minus 4, substitute in my y value of negative 2, and this is equal to my c. Notice this equation only has one variable, so I know I should be able to solve it. So 3 times 5 is 15, minus a negative is going to change it to a plus 8, is equal to c. So 23 is equal to c. So the final equation of a line with a gradient of 3/4 that passes to 5, negative 2 is 3x minus 4y equals 23. Okay. Let's see this when you have a negative gradient. So when you have a negative gradient, okay, we're going to get 3x, okay, plus 4y. So we don't have the negative there, which passes through the point of 1, 7. So again, 1, 7 here. This is my x. This is my y. So now I need to utilize that information to find my c. Okay, so I get 3 times x, which is 1, plus 4 times my y, which is 7, is equal to c. I get 3 plus 28 is equal to c, so 31 is equal to c. Putting this all together, I get that 3x plus 4y is equal to 31. There's the general form of the equation, the gradient of negative 3/4, and goes through the point 17. Okay, last example here. A circle has a center 2, 3. Find the equation of a tangent to the circle with a point of contact at negative 1, 5. So big thing we got to know here is that a tangent line is a line that just touches a circle and is perpendicular to the radius of a circle. Okay, so what I want to utilize is the fact that since these lines here, let's call the red line L1, let's call our radius L2. Because those are perpendicular lines, we know the gradients have to be reciprocals. Okay, because to find the equation of this line L1, I only have one point. So I need to either find another point on this line, or I need to be able to find the gradient of this line. So I don't have another point, so that alleviates that possibility, but I can find the gradient because I know it needs to be opposite reciprocals of the radius there. So first, I'm going to find the gradient of the segment PC. So change in y, 5 minus 3, over change in x, negative 1 minus 2. So 5 minus 3, I get 2. I get minus 3. So this is the gradient of PC. But I want to find the line, the gradient at P for L1. And since L1 is perpendicular to L2, and L2, that gradient was negative 2 over 3. A gradient that is perpendicular to that must be opposite, so it's going to be positive 3 over 2. So these two slopes, or gradients, we know are perpendicular. Okay, should make sense. Negative slope here because we're going downhill here, and we want a positive slope for L1 because we're going uphill. So now that I have my gradient, I can use my general form and say that this is 3x minus 2y, again it's opposite there, equals my c value. Well, I know that my point negative 1, 5 needs to satisfy that, so I'm going to plug in that into my x and into my y and solve for my c. So I get 3 times negative 1 minus 2 times 5 is equal to c. Get negative 3 minus 10 is equal to c. So c is equal to negative 13. Putting these things together, I get my final equation, 3x minus 2y equals negative 13. Okay, so that concludes our notes tonight. Highlight any questions you have and bring them to our next class.